Hi, so here we are with assignment 2 of Math 211, and basically I'm going to solve question 1 right now. It's not a hand-in question, so it's not essential, but I'm just going to sort of go through this so you can sort of understand the way I'm approaching these type of questions and my methodology of solving it. It's slightly different from the profs like I mentioned in my first couple of videos. So if you notice something that I'm doing differently, it's probably because I've seen it in Tenty's notes, and that's the way I'm going to do it. Anyways, so we'll start off with A, where it's x double prime, which is x, the second derivative of x, plus 3 times the first derivative of x minus 4x is equal to 0. So now the first step to any problem like this is taking the left-hand side of the equation and replacing everything with an m, every x with an m here. So what I'm going to do is look at the degree of the derivatives and replace it with an m to the power of the following degree. So this is the second degree of the derivative. So I'm going to replace it with an m squared. Likely, like this, I'm going to replace, since this is the first degree, derivative to the first degree, I'm going to replace it with just an m, and since this is not a derivative, I'm just going to replace it with a minus 4 is equal to 0. Now this is any normal quadratic equation, so the next important step is actually to check if b squared minus 4ac is greater than or equal to 0. So in this case, b is our 3, so b squared minus 4ac will be 9 minus 4 times, minus 4 times 1 is equal to 25. Now that's actually greater than 0. So you can go ahead and assume that your answer is actually going to be in the form of x is equal to c1 times e to the m1t plus c2 to the c2 times e to the power of m2 multiplied by t. Now how do we find m1 and m2? Well, you basically solve it like a general quadratic equation. So you'd go ahead and do a minus b plus or minus root b squared minus 4ac all over 2a. If you did this, you get a minus 3 here, plus or minus 5, because we just sub it in here, all over a 2, since a is 1 here. So you're going to get either minus 8 over 2, which is equal to minus 4, or you're going to get 2 over 2, which is equal to 1. You can just treat any of them as minus. M1 could either be minus 4 or 1, or M2 could be minus 4 or 1. It doesn't really matter. You can just go ahead and substitute that in right into your equation. C1 is equal to negative 4t plus C2 is C2 times e, where M2 is equal to 1, so it's just C2 times e to the power of t. So that's your equation, x to the t, and that's your general solution. They haven't given you any initial conditions, so there's no way you can actually go ahead and solve to get C1 and C2, and that's how basically the next two parts will work, B and C also. So this is going to be your final equation. If you have swapped these, it doesn't really matter, it's not going to change anything. So we'll move on to part B. So part B is basically the same, and if you've done this assignment before, there's actually a pattern that follows this. They want you to try all the conditions where b squared minus 4ac is greater than 0, less than 0, and equal to 0. So since we've already covered a greater than 0, I'd probably expect b to be either of the other. So let's go ahead and write it again. So it's double prime of x, well, the second derivative of x minus 4 times the first derivative of x. So let me just erase that. 4 times t plus 13 x t is equal to 0. Now we do the same thing like we did in the first question. This is x to the second derivative, so it's m squared minus 4 times m plus 13 is equal to 0. And then you continue with your b squared minus 4ac, which is going to be 16 minus 4 times 13 minus multiplied by 1, which is equal to, this is your 52, and that's going to be 36. So negative 36,